Hello, friends. How are you? Force. What is a force? Is this a force? Playing with a ball? Do I need force? See, I have placed it here and I am applying a force on it to roll it. This is a translation motion. And now, is this the force? I have squeezed the ball and its shape has changed. So, in the today's video, we will see all the concepts of force, definition of force, its vector form, how it is calculated, and its units. So, let's watch today's video. Engineering Fundamentals from the Appendix B, page number B-8 to B-10 from the manual detailing for steel construction by Yugandhara Talele. Content of the video is introduction, then rigid body. What is force? Unit of force, internal and external force. Some equations to obtain force. What is reactions? Some problems and summary in the end. Recap. We have seen supports in the structure, types of members and loads acting on the structure. For better understanding of the engineering concepts, please watch these videos before. The links for these videos is provided in the description box below. What is a rigid body? In the structures or in the mechanics, you will come across with this word a lot. So, let's see what is the rigid body. Rigid body. Rigid body does not deform when loaded, and the combination of two or more particles that remain at fixed, that is at finite distance from each other. And the parts of rigid body can have different displacement, velocities and acceleration if body has rotational or translation motion. Now let's see what the force is. Force. Force is any action on a body which tends to make it move, change its motion, change its size and shape is called force. It can be push or a pull that one body exerts on another. For example, gravitational force, electrostatic force, magnetic and contact influences. And the important thing is force is a vector quantity. It have both magnitude, direction and point of application. You might have played tug of war in your childhood. In that game, both of the players are applying force on the rope. They are applying a tensile force on the rope. Now we will see some of the examples of force. Pushing the door is example. Pushing another person is example of force. This is also the example. Here the direction of the ball is changed because of the force. Slapping the person. Example of force. Kicking the ball. Here the force is applied on the ball. This game you might have played in your childhood. Catching the ball is an example of force. Here compressive force is applied on the leg. Here, see, the crushing is done. So the shape of the bottle is completely changed because of the applied force. See? Now, what are the units of force? Unit of force are derived from the equation F is equal to ma. That is, force is equal to mass into acceleration. This is famous Newton's second law of motion. From this, various units of the force are derived. How they are derived? We will see. This is equal to mass into acceleration. Now, we will find out units in MKS system. In MKS system, unit of mass is kg, unit of acceleration is meter per second square. This kg meter per second square is also known as 1 Newton. In CGS system, unit of mass is gram, unit of acceleration is centimeter per second square. So it becomes gram centimeter per second square, which is also equal to dyne. Newton is equal to how many dyne? So 1 Newton is 1 kg meter per second square. So kg is 1000 gram and meter is 100 centimeter per second square. So we got 10 to the power 5 gram centimeter per second square. So the relation is 1 Newton force is equal to 10 to the power 5 dyne. Out in FPS system, F is equal to m, unit of m is lbm and unit of acceleration is foot per second square. So we get lbm foot per second square, which is also equal to lbf. Internal and external forces. So what is an external force? It is an action of other bodies on rigid body, is known as an external force. And if that external force is unbalanced, then it will also cause motion. Internal forces are the forces that hold together parts of the rigid body. Although internal forces can cause deformation of a body, motion is never caused by internal forces. This is the example of the structure. Here, force F applied on joint B is an external force. Here, now after the application of force F, there is sway in the body of the at level of BC, and the structure deforms like this. The member AC has lengthened by an amount delta LAC, and the forces acting at the end of the AC, TAC and TCA, are the internal forces. Tensile forces acting on the member AC. Here, This is the force F. Forces are frequently represented in the form of unit vectors and force components. Here, Fx is a force component along x direction. Fy is the component of force F along the y direction, and Fz is the component of z component of the force F in z direction. Unit vector is a vector of unit length directed along the coordinate axis. Used in vector equations without affecting magnitude. In rectangular coordinate system, there are three unit vectors, named I, J, and K. Here force F can be transferred along this line of action of force. Along this line, the effect of force will be same. The resultant or sum of F of n two-dimensional forces is equal to sum of the components. Like here, F is equal to Fxi plus Fyj. The direction of the resultant with respect to x-axis is calculated from the second equation. The components of two or three-dimensional force can be found from its direction cosines, like Fx is equal to F cos of theta x. These are the cosines of true angles made by force vector with x, y, and z axis. For this is how the resultant of force is found out. And from that resultant, the x component of force, y component of force, and z component of force are found out. Thank you so much to you all for being with me throughout this video. I'm grateful for your support. Happy learning! We will meet in the next video. In the next video, we will learn about moment couple. This is the AIC committee who prepared the manual detailing for steel construction. I am grateful to them. Thank you so much. If you find this video useful, then please share and subscribe to get notified about the new videos.